So we are on to question number 2 up here with regards to changing in mass. So the question goes like this. You have a mass of 60 kilogram. Can you predict the loss in weight at the top of your Sydney Tower, which is 305 meters above sea level? So therefore, when you think about this, right, this overall loss is not a loss in mass, but it's a loss in weight, because gravity gets a bit weaker as you get high in the air, right? Yeah? So, when you think about this, really, to model new weight is equals to mg. And my question really is about how much is g reduced. Okay? So therefore, when you think about this, right, g on top of the Sydney Tower, when you're trying to model it, it will have to be equals to g, which is the universal constant of gravity. And then mass of Earth, we can appreciate that, yeah? And also multiply by r squared. Now, first thing about r squared, what does that actually mean? It means, remember, when we talked about this before, it's the point-to-point separation between the two center of masses, right? So therefore, you have to go through 6,378, am I correct? Yeah? Meters, now what am I missing? I'm missing... Yeah, 10 to the power of 3 or 3 zeros up there. Excellent. Alright? But on top of that, I'm on top of Sydney Tower, isn't it? Yeah? So therefore, there's some extra bit of elevation. How tall is it?
305 meters.
305 meters, excellent. Yeah? So I hope you can see that where the danger of this question actually lies behind the, what you call, units, conversions and such. So therefore, the next bit should be easy. 6.67 times 10 to the power minus 11, and then times mass of Earth. Now, can somebody help me out up here? It's around about 6, isn't it?
5.974.
5.974 times 10 to the power of
24.
24, excellent. Yeah? Divide that by 6378000 plus 305. Do not forget about the square, which is a rather common mistake.
Oh, it's 9.79.
9.79. Can we get one more, Esther?
4.
4. Okay. So can we restart for you? Yeah. So after my girls diligently calculate this and I trust they have a judgment, they should get around about 9.794 meters per second, right? All right. I think it may be a bit too presumptuous to actually for me to assume that the what you call the surface gravity is 9.8. So therefore, let's calculate that one more time. I'm going to do this one more time, but this time on the surface of the planet, I'm assuming the radius equals to 6,378 kilometers. So when I do g gram, that would also equals to g times m over r squared. So 6.67 times 5.974 times 10 to the power 24. But this time, I would use only 637,800 without the addition of 305, and then square this down thing.
9.795.
9.795 meters per second square. Thank you very much. Excellent. Now, I hope you can appreciate that there's a difference in gravity, isn't it? Let's say that, for example, if I actually look at the weight on the surface of the planet, remember, is equal to mg, isn't it? Yeah? And according to the question, the mass in this case is 60 kilograms, so therefore I'll just put 60 times 9.795. And this should give me a weight. What would that be, ladies?
587.7.
587.7. Yeah, good, because you stick to 4 years up there. And this would be in the unit of Newton, isn't it? Yeah? Now we do this one up here. Weight, again, equals mg. But this time we use a slightly different g, the lighter one. What does that give you?
587.64.
So if we actually break together a subtraction, alright, I hope you can see that there's a differences. Delta in weight will be equals to 587.7 minus 587.64, which is equal to 0.06 Newton. Does that make sense? But now this question I like it because of the very fact that there's a very, very small variation. And this small variation really can only be detected if you actually have been saving your intermediate calculation in your calculator. So it's actually very quite crucial that you actually save those intermediate values, all right, into your calculator A lot of people didn't know that they actually got an extra 6 memory on your calculator. The way to do this, let's pretend that if the number I want to record is 1, 2, 3, 4, yeah? I go shift, and I go STO, stand for storage, yeah? I tell the calculator which one to store in. You got A, B, C, D, E, F to store in. Let's just say I store in B, yeah? You can see 1, 2, 3, 4, arrow B means it's been saved to B, yeah? To record, all you have to do is RCL, which stands for record, and then press B up there, B, well guess what, 1, 2, 3, 4. There you go. Yeah? So that's how you actually store extra memory on your virtual calculator and how you are doing those long physics calculators. So let's look at the question together. Alright, this is HSC 2006, I believe, alright, in section number 1. Alright, so therefore, basically, when you think about the situation up here, the first thing I would do is to try to draw the situation first. Alright, so planet, object, and then you will get the first one up here being 10,000 K. And then it actually go to a high altitude, which is now 20,000 K. And the question is asking how much more work will be needed to be done to move the object to a stationary point 80,000. Okay. So now I don't know whether you see a problem so far. Remember the way that we actually deal with this problem, FUCC, right? Find out what formula describes the whole situation. So GPE should be equals to negative G M1 M2 over R is equal to R squared. That's a common mistake. Yeah? But problem is this. If I try to do a direct substitution, right, what's the immediate problem that you will encounter? Did you notice?
Joules is possible.
Huh?
Joules is possible. In the question.
It is the differences or change in joules, right? We can work around that by actually doing subtractions and such. But what else stopping you from using this equation straight away when you look at the amount of variables that you're putting? What's missing? Mass. As a matter of fact, you don't have the mass of the planet or the mass of the object that you're lifting. Can you see that now? Yeah? So people, when they actually look at this situation, say, well, hang on a second, I can't substitute anything, therefore I'm dead. Yeah? But the HSC just let it play with you up there for a moment. Because we're trying to pick out those people who are just trying to do substitution and trying to actually just find an equation and dump numbers in it. Think about this, right? What they're giving you in here is a change in GPE. Yeah, a change in GPE. So therefore, when I'm thinking about this, right, how about I actually translate that into a piece of mathematical equation first? Yes? Alright? Remember in the previous lesson I told you before, you're trying to translate some of this situation into the equation, and then the maths up there, you're trying to work it out, right? So let's try to translate this. I don't want GPE, what I want is a delta GPE. Alright? A change in gravitational potential energy. And that basically is GPE at, let's say, 20,000 kilometer. I want to subtract that. What do you think I'm going to subtract that with? Yeah, you got this. Where is it? GPE. Actually, we should call that. GPE at 10,000. Does that make sense? Okay. So think about this, right? What is this change? Well, it is found that 1 megajoule of work needs to be done to move the object from 10 to 20,000. So therefore, between 10 to 20,000, there's differences in work of 1 megajoule, isn't it? So you know what? I'll do 1 megajoule up here. Now, be careful, mega stands for 10 to the power of 6. Excellent. Now, think about this next. Remember all this minus and such, right? Yeah? This can be extremely delicate if I'm missing minus up here. So should I put a minus? Now let's try to rationalize it. This is a higher altitude than that altitude. Yes? So therefore, which one should have a greater amount of GPE? At 20,000 or 10,000? Which position have more GPE?
20,000.
Lifting, right? Remember? Yeah? So therefore, a bigger number minus a smaller number, positive or negative? Which one? A bigger number minus a smaller number. has to be positive, isn't it? Yeah, does it make sense first? Because I'm going from a higher altitude to a lower altitude, relatively speaking. Yeah? So therefore, this difference is up there would be positive difference. Yeah? You can flip this other way around, but you actually get a negative value instead. Yeah, work both ways. Okay? Now, let's move on. Minus g, make sure that you write the equation correctly. M1, M2, and in this case, that's 20, sorry. And then minus again. Be careful about sign, yeah? G, M1, M2. Capiche? Yeah. So this is the first step. I try to translate a piece of information into a mathematical expression. Yes? Now, I'm an opportunist. What do I mean by this is, I got number. Guess what? Remember earlier on, I know my problem is I can't do the equation because I don't have M1 and M2, isn't it? If I'm really being dodgy, you know what? I can rearrange this and have G1, GM1, M2 as a subject. But guess what now? I have a number now. Can you see that? Yeah? Alright, girls, can I give you a couple of minutes? Can you work out what GM1, M2 be? So, thank you very much to the girls in my class. They have diligently actually getting these results up there, which we all across the board, we all agree on that value. Excellent. So, finally, let's have a quick look at the wording of the final part. Can you calculate how much more work is needed? See, a lot of people actually just go type in the value for 80,000 straight away. But the question is not asking what's GPE at 80,000, but rather how much more work you need to put down, all right, to get to 80,000 K. But hang on, we've got a problem. Where did we start? Did we start from here, or did we start from here? Can you see now? It's very, very tricky, isn't it? This thing up there, when you look at the wording, it could have been interpreted both ways. I could have interpreted starting from 10,000, or I could have said that I start from 20,000, because which point is the original point? Was this thing just a hypothetical discussion, or was it actually a literal movement and such? Now, in the official answer, they stated as from here to there. That's the one move they're looking at. But you know what? If you stated from here to there, and you explain, assuming that the original point of motion start from 10K, you know what? You get full marks for it. Yeah? So therefore, when you actually got ambiguities and such for these kind of questions and such, right, can I please ask you to articulate your thought, write down step by step, assume X, Y, Z, etc., and do your calculations. Yeah? It will save your life, all right, in calculation in particular, when wording becomes ambiguous and arguable. Okay? So let's work on the assumption version that we start from 20K. Okay? Assume we start from 20,000. And I hope you can appreciate that. Delta GPE, again, it's change of GPE, not the absolute value of it, yeah, would be equals to GPE at 80,000 minus GPE at 20,000. So in this case, all you have to do is substitute this thing up there, because that's stands for GM1, M2 up there, right? So minus 2 times 10 to the power of 13 divided by, in this case, 2,000, 1, 2, 3. Alright. And then minus again, don't forget that sign up there, yeah? 2 times 10 to the power of 13, and that's 20,000 kilometers. And again, don't forget the conversion again, alright? Because this is kilometer, you need to convert that back to meters. Alright, so based on our work together, we actually all agreed upon the what you call recorded value, calculated value, which is 7.5 times 10 to the power of 5 joules, alright? Pressure point up here, please have UCC it. Double check your formula. Did you miss a square anywhere? Yeah? Unit, was it the appropriate unit? Make sure that the conversion occur, alright, between kilometers and meters. And finally, do not forget about significant figures. So if you go back to the question up here, I don't know whether you can appreciate this is the shortest number in the entire list of them. Yeah? It doesn't say 1 megajoule, but say 1.0 megajoules. So therefore, I hope you can appreciate it's actually too significant involved. So therefore, to yourself here.